this is going to be a more in-depth version of what we spoke the other day. This course is usually for around 2.5 hours, but I guess here I'll keep it short by just giving you guys the entire flow. So you're going to see about, you'll have an introduction to blockchain technology, consensus mechanisms, intro to cryptocurrencies, wallets and types of wallets, Web3 basics, and development basics. So obviously the first thing is what is blockchain, and do you, any of you have any inputs on this? If you guys have read through it or if you had done any research on this? Anyone? All right, no issues. So yeah, again, blockchain is a type of database structuring. It's where you put a certain amount of data in a block and then have the next set of data in another block and then connect these two blocks as it goes. We use these kind of operators traditionally in computers itself, especially within encryption. It's called the Cipher blockchain protocol. But the Cipher blockchain protocol basically works only on centralized entities such as servers or one key distributing agency. Um, in a sense, it's basically like an never-ending list of records. It has unlimited space, basically. As long as there are nodes, there will always be space for them to save this information. The basic block will contain a cryptographic hash of the previous block, timestamp, and the transaction data. The timestamp proves the transaction data existed when the block was published in order to get into its hash. So what happens here is a lot of people will basically be sending a lot of cryptocurrencies here and there. All of this information is saved into a block and then put out for mining. Whoever becomes the validator will be able to open this block, verify the transactions, and then post them on the chain. So during this process, the miners or validators obviously need to get something in reward. They're not just doing this for free. Although the entire operation is completely automatic, it's not like you have to sit behind the screen and do any coding to mine. It's just like running a very heavy software. So this person will also get rewarded with certain cryptocurrency of that mining entity. So if you mine Bitcoin, you get a little Bitcoin. If you mine Ethereum, you get Ether, and so on. There are different valuations, different types, different factors that affect what the entire valuation should be. So few properties of blockchain is it's immutable, it's verifiable, meaning it's trustless, and the data can be accessed by anyone anywhere as long as they have an internet. There are ways you can also do this without the internet, but that is something we'll dive into much later. There are few types of blockchain, mainly two. The first one is decentralized, which is distributed in nature, and the other is centralized. It is running on a central server, probably on an Amazon S2 backend, but both of them will eventually do the same purpose. The centralized people have complete control of the change. When it's decentralized, all the nodes have control. So if they need to make a change to the entire network, then more than 51% of the nodes should vote yes, or basically take the update with before a time stamp, like before a certain time. And then if that is more than 51%, then it changes into that. So that is what we call a fork, Fork, when a certain blockchain forks itself. So what is blockchain tech?
Excuse me,
Yeah.
I had a doubt from the previous slide. You
Yes.
talked about the uh, like cryptocurrencies miners, they getting rewarded for
Yes.
that thing. I didn't get understand like how they are rewarded with.
Okay. You'll get a better understanding of it. So one main aspect of block. So this over here is just what blockchain does generally. And then here is where we use something called blockchain technology. So within blockchain or within the computing world, there are two problems. One is the Byzantine generals problem, and the other is the double spending problem. The double spending problem basically means that you can make copies of anything on a traditional computer. It is really easy to make copies. And the entire backend system and the internet is based on making these copies and sending copies. So what happens is when you send a mail, it's not like the mail is leaving your presence and then going to somewhere else. Nor is the same for sending messages or anything like that. So meaning you can send the same set of information to two people. But here, because blockchain uses, Bitcoin or any cryptocurrencies use blockchain as a underlying technology, this double spending problem also exists. Now, the other problem is Byzantine generals problem. So Byzantine generals problem is a general problem that anyone in the distributed computing world will face, which is if you have n number of nodes, how do you ensure that at least 51% of that n number is always in sync, that one string of data is the true one and all the others are false. So to solve these two problems is where Satoshi Nakamoto, the inventor of Bitcoin, invented something called proof of stake. So proof of work, my bad, proof of work, consensus mechanism. So in proof of work, what happens is, so this is who or how a validator or miner will do the validation. So here, let's say you are a proof of work miner. To reach Bitcoin's hashing power, the required hashing power to mine a certain block takes a lot of electricity and a lot of processing powers. You can check this out on, because the entire system is completely decentralized. You can get most of these informations like in very, very ease of, like, just getting all the, no, I went to the wrong thing. Well, basically the entire information is open. So here you obviously get the rates and the general trading value, the estimated hash rate, the number of transactions in 24 hours, transaction volume, how many Bitcoin was sent, and estimated transactions. So over here, you can see the size, the memory size, the price chart, the latest blocks that were mined, the latest transactions that happened. If you click on a transaction, you can see that it is from where it is coming from to who it is going to, depending on which protocol. This is where wallets use various protocols for them to see how these entire blockchain communicates with each other. But the only thing you will know is the transaction hash and the wallet address. You won't have a name or anything as such that will tell you what to do. Where did they change? Yeah. So here you get all the other in-depth information that happens, all the market capitalization, exchange rate volume, market price, all the block details, mining information. So this is where we will basically come into take a look. This shows who are all mining how much and how much Bitcoin they're all getting per mine. And this, so this is a pie chart of the entire um, mine rate. So you would need to constitute to at least 12.5% of this entire processing power to be able to mine. Now, when you mine, and because this is proof of work, you have to invest a lot in processing power, electricity, and infrastructure. So these are basically big amounts of computers or graphics units that work together. For the sake of Bitcoin, we have a very specific miner called the ASIC miner. ASIC stands for Application Certified Integrated Circuit Miners. So this is basically a miner meant to do only one thing, and that is to mine Bitcoin. Now, when you get a block and then you confirm it, you get rewarded for doing this. So this is where someone just asked me a question, right? So because of all of this investment and all this work that you're doing to ensure the infrastructure security and the general security of the blockchain, you are being rewarded with something as a thank you. Now, the reward factor is very subjective. It depends entirely on the blockchain. In the case of Bitcoin, you get rewarded. It started with rewarding you 50 Bitcoins per block. And then every 4 years, it keeps halving out. So from 50, 20, 25, 25 to 12.5, from 12.5 to 6.25. So we are now currently in the 6.25 range. In April 2024, the next halving will happen. And then you will start getting only 3.125 Bitcoin per block that you get. So the idea behind this is to make it deflationary. Anyone knows basic economics is if you restrict the supply of something, the demand is prone to go high. And if the demand goes high, you also have the price action that follows it. So this way, up until now, um, so totally there are only 21 million Bitcoins. How it reaches this 21 million Bitcoins is you take the Bitcoin reward that was given at the first, and then you calculate. So there are basically like 486,000 blocks a year. So doing that by 4 years, you get like around 16,000 blocks, 160,000 blocks, 1.6 million blocks. Now, if so, the program is written in such a way that after X amount of blocks has gone, then the reward has to be halved. So as the time goes, it will reach that certain block number, and at that block number, from the next block on, the reward will be made half. So now these miners have invested like let's say $15,000, and then their reward was 3 Bitcoins. So for them to reach break even, they will have to sell each Bitcoin for at least $5,000 so they can even break even. And if they're not able to do that, then that mining process is not good enough. Now, miners are the only people who get new Bitcoins. Everyone else is using an already existing Bitcoin. Now, if you calculate this 50 for every from 50 for every 4 years, it keeps halving, you will reach at the number 21 million, or that is 21 million point eight zeros. How Indian rupees or how US dollars have $10 and 20 cents, 50 rupees and 25 paise. We have one Bitcoin and X number of Satoshis. So there are 8 decimal places for and each so the decimal place is one Satoshi. In proof of stake, you have to do this entire same process, except instead of investing in processing power, infrastructure, and so on, you have to stake the native currency to become a validator. So if you want to become a Binance Smart Chain validator, you need to stake 50 BNB coins. That is BSC's a native currency. For ADA's chain, you need to put, I believe, around 1,000 ADA. When Ethereum goes to version 2, that is changing from proof of work to proof of stake, um, it will require 32 Ethereum to become one staker. So if you become a staker, then you become a validator. If you're a validator, you'll be offered blocks. If you do the processing correctly, which is automatic, you will get rewarded with 2 ETH in the case of Ethereum, 10 BNB coins in the case of BSC, and I believe 50 ADA. So this will keep changing, and they can change according to it, but usually they don't. It's already encoded. So yeah, I hope this answers your question on the reward factor.
I'm still a little confused. I mean, like, how do they, from where do they get the Bitcoin? Like the miners, who issues them, or
So,
like,
so it's issued by the nodes itself. It is programmed in a way that if you reach this amount of blocks, you have to do this. If it reaches this amount of this, then you have to do this. So these are
okay,
predefined information given to the blockchain when it was developed in the beginning.
okay, then I get. And
So this yeah.
why is like ETH changing from proof of work to proof of stake?
Well, proof of work, we can't deny the like the not the polluting aspect of it, but the effect of using such electricity. So to put things into perspective, you would need Facebook servers, Google servers, and probably the entire Microsoft servers all together to even come close to becoming one node in the Bitcoin entity. So if you look at the metrics over here, it will tell you that you need
So basically, the bigger the blocks are, the processing power is more. Required is more.
no.
So
There is another restriction over there. According to the code, each block
Sangeet,
can
we are
only.
losing you.
Can you hear me now?
Yeah, yeah. Now it's
You can hear me? Hello?
Yes, we can hear you.
Okay. So basically, there's another restriction over there. The restriction is that you cannot change more, you cannot be more than 2 MB per block. 2 MB is the maximum that a Bitcoin block can be. So whatever information or transaction details that you're putting will be limited by 2 MB.
Okay, and
Because
you said about that the processing power required is
yes, sorry.
total.
So
Uh,
you go to mining information. This is your hash rate required. So you currently, to be part of the chain, you need around 201 tera hashes worth of processing power. Wait, let me just be sure that I am at the right one. Okay, it's 221 million tera hashes per second. So there is a calculation that you have to do that I didn't put up in the course yet. But this basically tells you what denotes to the memory size of a block, which is basically all the hashed values of the information using the 256 bit encryption hashing algorithm. So you can calculate the 256 like around X number of times, which will eventually reach close to 2 MB. And this is only if there are
so
that
the
many transactions.
okay, sorry. So the processing power that is different for different blockchains, right?
Yes, it is different. That so the what denotes to the processing power is the network difficulty. So the general idea is if a block is given to me and I break the block in X amount of time, then the next block will be slightly harder. Basically, the prime number used in the core encryption or the hashing and algorithm goes by one goes to the next prime number. And you guys very well know that in encryption, the bigger and stronger the prime number, the bigger and stronger your total randomness, right?
Yes.
Yes.
But
So
this uses a lot of energy.
it's a lot of energy. Yes, unfortunately, that is the problem, and that is the hate that is coming towards the entire Bitcoin ecosystem. But what you need to understand is if you compare Bitcoin and what it does, and you compare our current solution to the exact same problem, which is the entire financial system, Bitcoin basically takes like 5% of that. And this I'm saying for all the computers, all the clerks, their salaries, ACs, rent, all sorts of things. Everything that comes to make that financial system survive, which honestly isn't doing a good job. Um, this uses only 5% of the entire energy over there. So yes, it does take a lot of energy, but what is it trying to achieve is where people are, they're still not able to accept it. So whoever comes in right now, we tell them that you guys are definitely early for the entire um, technology boom. So probably in after the next 4 years is when you're going to see, or April 2024 is when you're going to see mass adoption take place. This is because in the previous bull run, we saw that a lot of retailers, like common people like us, took interest. In this bull run and the previous bull run, we saw that there are a lot of interests from companies and organizations. And the next bull run is basically, they say it's going to be among the governments who will achieve more, which China already has done a very good job of getting around 666,000 bitcoins in the name of China. So there are a lot of things that come with it, a lot of pros and cons. But I guess that's the problem of true decentralization. It shows humans for exactly what they are and their true emotions within them. And that just shows a lot of things. But this is a conversation for another day. So, yeah, that's your two most frequently used mining or consensus mechanisms. There are more. There's proof of authority, proof of history, proof of ownership. There's a lot, and they all ultimately do the same thing. You have to put in something that you're willing to lose, and if you don't do your job, you lose it. So here, if you don't mine properly, you lose what you've staked, and here you lose all the electricity that you give it, because you're not going to get rewarded for it, and that electricity you have to pay out of your own pocket. The next is cryptocurrencies. So cryptocurrencies use consensus mechanisms to be built on top of the blockchain technology. So here, what it uses blockchain for is verifying transactions. So if you go to the not exchange, uh, so yeah. So here you can see the latest transactions, all that is happening that I've showed you, and you can get this one thing called transaction hash. So if you have a transaction hash that is like 8 years old, if you come and paste it here, you'll be able to see that transaction, and it will be the same transaction that was put on that day as well. So this is basically your reference ID, if you want to call it. For if you buy something, oh, this person just sent 15 bitcoins. This person just sent 258 bitcoins. Okay, something's happening. Anyway, so you get, because of the whole true decentralization nature, you get like live metrics as it's happening with the timestamp. You click on a hash, you get more details about it, considering who mined the block, the weight of the block, the memory size, the status, how much it's worth at that time, and the fee that is going for the miners. So there is one more thing that I forgot to tell you. When you become a miner, you don't only get block rewards, you also get all the transaction fee in that block. So if within, let's say, let's go check out a block number. Yeah, latest blocks. So this block was mined by F2 pool. It had 1150 transactions. It was timestamped at this. You only need one confirmation per block because that will be the primary node, the Merkle root of the hash, which you can't honestly do it, and the difficulty points in bytes, which will, so this is the amount of bytes of information processing you need to process this particular block. So the next one will obviously be slightly harder. The version of the entire thing, number of bits, the weight, the byte size, and block reward 6.25 as I mentioned, and fee reward. So this point 0.29 was the transaction fees all the 1150 transactions had paid together, and this goes straight to the mine. Nobody takes this. So your reward is basically 6.25 bitcoins plus 0.02. So it's basically 6.27 bitcoins for a 10-minute work. So let's see how much that is. Yep. So that person just made $253,000 in 10 minutes. Now, how much of this $253,000 he'll have to pay for electricity and things like that would be quite high, but then it will basically, in a way, be compensated. So yeah, that's on the mining side of things. So yeah, a cryptocurrency is a form of payment that can circulate without the need of central monetary authority, such as a government or a bank. Instead, cryptocurrencies are relied using cryptographic techniques that enable people buy, sell, or trade them securely. So now, imagine if you could put a certain script that runs on all of these nodes. This script is what we call as a smart contract. So you can, instead of, right now you are interacting between your wallet to the blockchain to another wallet, but sometimes you can interact only with the blockchain and back. So this is when you put a script on the blockchain, which is called a smart contract. And then with your wallet address you interact with that smart contract. So this again goes into a little bit in depth. So, but it'll definitely, if you guys are here for the long run, then the entire course you'll understand the entirety of it. So cryptocurrencies can be exchanged for goods or services through, as they often use in investment vehicles. Cryptocurrencies are also a key part in the operation of some decentralized financial networks. So we provide financial services generally, like giving loans, giving, um, lending it, taking loans, and then providing like all sorts of financial instruments, securities, bonds, and so on. So we have a cryptocurrency version of all of those in the crypto market, just that it's decentralized and peer-to-peer. No central company or anything works. So cryptocurrencies are applications that use blockchain, a consensus mechanism built on the blockchain technology. So the next is cryptography, one of the main pillars of cryptocurrencies. And I'm sure you guys don't need an introduction to cryptography, but if you do, it's essentially the practice of encrypting certain data or information so that it can be kept in secret from third parties. Cryptography has been used for everything from allied forces sending military messages back and forth during World War II to Julius Caesar using ciphers and so on. So cryptography is basically the digital version of hiding information and sending it. Why is it needed? Well, you know the amount of hackers that are out there and that will do anything and everything to get your information. So giving something such as $10 million or $15 million is something of a concern that you would want to keep private. How does it work? So there are two basic entities. There's symmetric encryption and asymmetric encryption. We use asymmetric encryption, especially the RSA-256 version of it. And for hashing, we use the SHA-256, which is the secure hash algorithm, 256-bit. And wallets. So a wallet is how you interact to a blockchain. There are different types of wallets. So you have a soft wallet, or a hot wallet, where you have to just put password, holy shit. And you log in to your wallet. It shows you what you have. You can create any number of wallets. You can choose the mainnet, whatever mainnet that is you want to talk. And let's interact with a certain tab. So let's go to Uniswap. Uniswap is a decentralized exchange that runs on the Ethereum network. So you go to launch app, and now you have connected your wallet. So now you can sell this to Matic for any of the other tokens that you want, and then it'll do its conversion, blah blah blah. And then if you have enough funds, it will give you another prompt over here, and then you just have to provide your signature. As such, you have hard wallets, which are basically pen drives that hold your wallet keys, and then you have multi-signature wallets where you need the signature from multiple wallets to initiate a transaction of sorts. We'll get later more deeper on this as well, but this is kind of one of the main factors that ensures everything sticks in place. Smart contracts, as I mentioned, is a basic program or a script that is saved in these nodes in the blockchain. And you will get something called a smart contract address, which is similar to your vault address. But when you interact with the smart contract address, you initiate a process. This process can be anything: send money from A to B, save these 10,000 image data. So that's where you see NFTs come into play. Have 50,000 of this coin, send 10,000 here, 10,000 here, 10,000 here, and then whoever sends this much ether, send this much of of that particular coin to them. So these kind of object oriented entities is what you will put on these smart contracts and save them on the blockchain. Now the main thing that underlies all of this. So Web3 is where you utilize blockchain for organizational and well more requirements than just sending money from one place to another. You use the blockchain itself to run your business requirements and so on. In very simple terms, everyone knows that there are three main entities of access control. One is read, the other one is write, and the other third one is execute. With Web 1, that basically existed since the dawn of the internet all the way till 2000, I would say, was just getting read access over the internet. From 2000 till 2008, we had Web 2. We still use Web 2. We use, I mean, 99% of everyone's infrastructure is still Web 2. So here we only have read and write. So this is where you have your you log in using your username and password, you communicate with servers, and then the data is saved on a database. In Web3, you get to also execute. Sorry. In Web3, you also get to execute certain things that have permanent changes and actions without having, like if let's say you want to migrate your servers from AWS to Azure or Apache, you would obviously need to ask your supervisor if you can do this. You need to tell AWS that, hey, I want this to change from here. And there'll be like a lot of formalities. But Web3, you can't do that. You are talking straight to the main source entity. If you want to take a decision, you can take the decision. You'll have to pay a little fee to make this process happen. That's it. So you log in using a wallet, you communicate with smart contracts, and then the data is saved on the blockchain. So this is the main difference between Web 2 and Web 3. You can use this information for anything. Imagine logging into websites with your wallet. So there is no name or anything, just that only you have the private key and therefore only you can access that wallet, meaning it is an actual person, but you don't know who that person is. So this is where KONMA has been building or planning to build a lot of these applications using Haskell. Imagine, so we have something called KONMA Hood. So KONMA Hood is basically a Web2 based decentralized community forum where you guys can join, come start a tribe of your own, and then have this. But as you guys can see, this thing still has my name to it. But if there was a way where I can change my name to my wallet address, and if I want, I can give my data such as my photo and anything else, and then bring it out like that. So these are kind of the applications that you will be building with KONMA if you choose to come with us. So development basics, there are four main entities. You have the language, the compiler, the nodes, the protocols, and the wallets. The language is the underlying language with which you communicate to a certain blockchain. If you want to communicate to Bitcoin's blockchain, you use the S script language. If you want to talk to the Ethereum based chain, you need to use a language called Solidity, which is a base of JavaScript and C++. And if you want to speak to KONMA chain, or if you want to speak to um, Cardano's chain, you need to speak only with the help of Haskell. A compiler is obviously just like any other compiler. It converts your code from something we can read to something only computers can read. So basically binary. The nodes are where the software to run the entire system stays. So this software is not in one node. It will be spread across any amount of nodes that the people willing to take part in. If you are a node, you obviously get a certain share for helping keeping your phone as a node, because the node is where you essentially mine. The protocols, the rules and regulations, these smart contracts, these cryptocurrencies work under, and how it is. Most of these entities are entirely open source. And then your wallets, exactly, which is your instrument to communicate with these blockchains. Things on the blockchain: fungible tokens, non-fungible tokens. So a fungible is something that can be exchanged by itself. Meaning if I give you a 100 rupee note and you give me a 100 rupee note, we have basically conducted a null trade because both the 100 rupee notes are the same. So now imagine if, so those are what fungible is. I give you 100, I can replace that 100 rupee note for another 100 rupee note. Non-fungible means, what if the 100 rupee note that I gave you was made of gold and the 100 rupee note you gave me was made of diamonds? Obviously, there's a difference in value. Even though they're both 100 rupee notes, the way it is made or the rules it follows is completely different. So meaning I cannot exchange one for another unless it is the exact same. So this is what we mentioned non-fungible tokens. Technically, fungible tokens will have a linear numbering phase, which is from 1 to 10. So if you say to 21 million bitcoins, it starts from 1 all the way till 21 million. Non-fungible tokens will have an ID next to it, another extra array of information or data stream, which will be able to consider it a transaction hash for that particular action. So if you have NFT, let's say that there is an NFT collection of 10,000. So this means all 1 to 10,000 is the same. But let's say you have 1A, 2B, 3C, 4D, 5C, and like that. It keeps increasing as it goes on. So now in 1A, you can have 10. In 2B, you can have 2. In 3C, you can have 70 and things like that. So this is where you make use of non-fungible tokens. This helps you prove some sort of ownership with the wallet address. Apart from just sending money from X to Y, it shows that, okay, this person has this particular token. If he has this particular token, then he is the true owner of it. If anyone makes a copy of it, you can obviously verify it on the blockchain by just following simple steps. The other thing is smart contracts, like I mentioned earlier. And the third are oracles and storage modules. So there is a saying, once you put something on the blockchain, it is forever on the blockchain. You can't really change it. So what if there are metrics that you want to give from the real world, let's say weather metrics and things like that, to a smart contract, but you cannot change it. So what you do is you query certain parameters or certain data arrays to an oracle, and you have the oracle collect the data that keeps changing. So if the change in the oracle happens, then that particular change has happened in the contract, because the information the contract is seeking from is the oracle. The other is a storage module where you basically store information in a decentralized manner. Few of the basic descriptions. Altcoin, a cryptocurrency, that's an alternate coin that works
Can you
similar.
can you go to the previous slide?
Yes.
So this concept of fungible tokens and non-fungible tokens, these are
Yes.
not applicable for just one. Like they
No,
have to be.
this is a blockchain concept that can be
Like,
used in any blockchain. To make use of this thing, you need to have smart contracts enabled. So there are very few chains that have smart contracts enabled. So,
okay, and I didn't get what is an oracle. I mean, what it is.
so an oracle is an off-chain database or a data collection entity that takes certain data, does the processing, and provides certain metrics to the smart contract to process. So let's take an example. I am making a smart contract which says, if anyone initiates or anyone communicates with this smart contract, the smart contract should first go to facebook.com, ask for their username password, and then check what their profile picture is. The smart contract should then download this profile picture and change it to um, whatever new profile picture that they're bringing. If they don't change the profile picture, then keep it the same. Now, whatever image is on your profile picture, you want it also on a Web3 entity. So you connect this profile picture to the Oracle, and then you connect the smart contract to the Oracle. You tell the smart contract, change the image, put the image, whatever is given in the Oracle. The Oracle's functioning will be, whatever image is put on Facebook on live update, change it in the Oracle. So you change an image in Facebook then changes it in their servers. The Oracle makes sense of this. And now, because the Oracle has made sense of this, the smart contract will also make sense of this. One thing I can clarify is this Oracle has nothing to do with the Oracle company. It's, I don't know why they chose that word. I guess they don't have any other words to choose from. But this concept of an Oracle is and has nothing to do with the company Oracle or any kind of connection. They didn't develop this. It's not theirs. They don't have any IP rights or any protocol rights as such. So if you're
Okay,
ever
and
searching
what?
for these kind of common entities between Web 2 and Web 3, make sure you use quotations and put Web 3 or crypto. So if you put Web 3 or crypto, then you will get the information based on that. It's pretty simple, I mean, I'm sure you guys know how the internet works and how messed up the algorithms. So now if I put Oracle, there you go. I get the Oracle Corporation, at least for the first 3-4 entities. Now I put Oracle in crypto, I get an entirely different set of outputs. So please be sure to uh, add this because it's really easy for getting this information, especially because there are a lot of corresponding and correlating entities that were completely different.
Sangeet, your voice is a little far away.
Okay, this is better?
Yeah.
Yeah. So yeah, just make sure you put Web3 or crypto when you make queries on Google.
Okay, so like in the that slide only in the Oracle one, what was the storage module?
So a storage module is basically an entity where you can put certain data and you cannot change the data after you put it. So we use something called IPFS, which is Interplanetary File System. You can install this and you basically upload images into IPFS, and then in return you get a hash. This hash is then provided to the block smart contract. So the smart contract will check the hash. The hash will lead to IPFS's hash, and then it will show the image that is saved on IPFS. This is because, like I mentioned, each block has a limited space. You can't just put like 10 MB images, 500 MB images. So what they do is they'll put the like any amount. Let's say you put a 10 GB file into IPFS, and then now you get a 32-bit hash. And you guys know how hashing algorithm works. You put one word or you put the entire Harry Potter series. If you ask for a 32-bit hash output, you will get 32-bit characters. Shall we do a small test? So two crazy things about hash. So when you put in any kind of plain text and then you generate a hash, you get the hashed output. I'm sure you guys know hashing already, so I don't think it's going to be an issue. So let's copy that and let's paste that. So this is the hash for my name. Now let's remove one letter. You would think that the hash would not change as much, but surprisingly, the hash will change more than 50% of the characters. So this is something that we get to make use of. The other thing is, if I put even one letter, I will still get the same length of hash. Now, if I put the entire page string, which is basically this much of information, and I generate, I will still get the same length of hash. So this hash is what is being saved on the blockchain, not this information over here. But the thing is, this information is be saved on IPFS. When the smart contract says, hey, look into this hash, it is going to look into this information. It will process this information again using the same hash generator, and it will verify if this is truly equal to the same hash. If it is, then you have the process. And I'm sure you guys already know how hashing works. Do you want me to explain what hashing is? Awesome. So that's hashing. And yeah, you have a lot of you have the general developer ecosystem for most of these things. You have information desktop environments, you have a lot of open source code. The entirety of blockchain kind of represents the Linux foundation. So we develop with the mindset of open source. The best part is, let's say you go to, so this is an NFT collection on the Ethereum chain that currently has a valuation of at least $3 million per NFT. So it has a verified tick here. There is totally 492,000 Ethereum volume traded. The floor price is 109 Ethereum. There are 6,000 owners and 10,000 items. And this is how the NFTs look. So let's say you click on an NFT and you go to details. You have the contract address. You click on the contract address. You go to scan, and here you have the contract. Now you look at the contract. You have the code. You have the open source code, that how this particular contract works. You can download this code and then you can make few changes according to what you want. Let's say you don't like the name, you want to change it to something else. You want to change the number of ERC721 tokens that are there, and you have comments, you have analytics of that particular contract that you can use for further information tracking and so on. Big events as part of what has happened. Obviously, all metric ID. You have the token ID, the 256 integer, the index topic, the address from to, and yeah. So as such, because the entire thing is decentralized, you can track it. But no matter where you go, you will always end up with a transaction hash. And then in the transaction hash, you are going to see who it is from. Now, this who it is from, it is very hard for us to co-associate a name. Like I showed you, it is very easy to create a wallet. You can just go over here, click that, and you put create account, then you put whatever name you want. So this name is used as your randomized nonce, and then now you create it, you have another wallet. No KYC, nothing stopping you. There is no correlation between the previous wallet and this wallet. Now you can use this wallet to sign and do whatever. Now obviously I just created the wallet. So if I search for this wallet, you're not going to see any transactions as such. But if you go to my previous wallet, let's say this one, I copy it and I paste the wallet, you can see the transactions I've done. Now you know that this wallet belongs to me because I voluntarily showed it to you. So people without knowing will show this online like, hey, donate this to my wallet. Oh my god, I just got this NFT. So if you say I got this NFT, they're gonna be like, oh shit, he got the Board ABR Club 4470. Okay, we have to go down. Oh shit, it says it's owned by this guy. Now I go this guy, I have his wallet address. That's it. Now I know who this person is. I know how much NFTs he has. I know how much his wallet is basically worth, and a lot of unnecessary details have gone out. So if some people prefer this, if you're like famous and you're like, hey, I want my name to go out there, you can provide this information out there. But unless and until that's really necessary, unless and until you voluntarily give this information out, is when they will know that you are the world. So yeah, that's just some extra things to be careful of. We're at 2 o'clock, so I'm just going to take 5 more minutes. An altcoin is a cryptocurrency that works similar to Bitcoin, but with modifications such as being able to process transactions faster. Blockchain, a structure for storing data in which groups of valid transactions called blocks form its chronological chain, with each block chronologically and cryptographically linked to the previous one. Consensus protocol, a process encoded in software by which computers in a network called nodes reach an agreement. Cryptocurrency is a scarce digital asset defined in the blockchain protocol. Decentralization is a hard way of measuring any attacks and is broadly controlled by distributed networks. Distributed ledger technology, DLT, it's a way of keeping these transactions. A fork is a way of, how GitHub works. You have a code and you fork it and then you make changes. A hard fork is when the main chain itself changes its way of functioning. Hash function, how it hashes. Initial coin offering is similar to initial public offering, how companies basically increase valuation. So there they give shares and stock and then they get money in return. Here you give cryptocurrencies and then you get money in return. Mining is people use this as a way of fundraising and raising money. Mining is the process of each nodes in Bitcoin, Ethereum, and many other blockchain come into consensus that this is one true set of information. Permission blockchain is basically a centralized blockchain. You have the proof of stake and novel consensus protocol in which instead of mining, nodes can validate and make changes on the blockchain. Proof of work, consensus protocol, choice of Bitcoin. To add new block, miners must calculate a hash. For that, it meets certain narrow criteria. Doing so requires an enormous number of random guesses, making it a costly process and deters attempts to commit fraud. Smart contract is a program that runs on the blockchain. So this is the entirety on blockchain on the fundamental side. There is obviously more courses to look into. So KONMA in general is a proof of stake blockchain that is a layer 2 solution to Cardano. Now, because there are a lot of transactions being done in Cardano and the transactions are becoming delayed, we are planning to build a layer 2 solution where we process these transactions and put all these transactions bundled up as one transaction into the main chain. So we are also going to be a smart contract platform. So we will need a lot of developers. The things that we plan to make is based on real world entities. So our whole idea here at KONMA is to make blockchain for one singular society that has the entire aspect of things completely figured out. So we currently look into 15 sectors. All of this information can be made available to you if you guys want to read more about KONMA and see how we work exactly. But to just put things on an easier aspect, these are the 15 sectors that we target. So we are well capable of being our own self-sustained.
Hey, can
Yeah.
you go to the PPT 13 slide? I mean, the question is about Oracle and that storage module. What is
Yes.
that? I didn't really get the difference. I mean, you could also use a storage module and with a
But a
contract.
storage module, you cannot change information. You can basically upload a data file. This data file is hashed using a certain hashing algorithm, and then you use this hash as the base URI. Meaning, if I want to search for some sort of data that is permanently there on the chain, you will use a storage module. So
Oh,
here, if you look at it and you look at this particular NFT, if you go all the way down to details, it will say metadata is frozen, meaning this metadata cannot change. But if you take this data or the metadata of the particular NFT from an oracle, then it becomes dynamic. It does not become static. So now let's say you want the color of this teeth to change according to time. So if it is daytime or if it's between 10 to 5, it is green, 5 to 10, it is red. So now this dynamic entity will be fetched from an oracle. So an oracle that we use very frequently is Chainlink. It's a decentralized form of an oracle, which has its own kind of consensus mechanism in it. So yeah, I hope that answered your question.
uh, yes, it is clear now.
Clear now? Any other
Yeah.
questions, guys? So yeah, that's it about KONMA as well. So we'll be building all of this. We are a Web3 company. It's completely work from home. We have a lot of factions under KONMA, sorry. And you have upskill where you can learn under me on the development and fundamentals of blockchain. We have a decentralized marketplace for art, lifestyle, and food. We have a dex that is needing going to be built. Our entire team details is here. So if you want access to this, please let Satya know. We'll be more than happy to send this to you. But in a gist, KONMA Inc. deals with all the commerce activities of KONMA. KONMA Labs deals with all the research and development for KONMA. Foundation is the NGO side and entirely community fronted. KONMA Hood is where we discuss or our community social media platform. Ambassador is an affiliation program where you can refer products from our marketplace to your friends, and if they buy it, you get a commission. KONMA Experience Center is a physical entity that where you can come and do any of these over here. KONMA Hope is our fundraising platform. KONMA Flair is our internship platform, which is where you guys have entered. KONMA Upskill is where you will start getting upskilled on various programming languages depending on what part you take. So KONMA Upskill is where you will be next. And after KONMA Upskill, you guys will join KONMA Labs as developers, or if you feel like you will fit somewhere else in the entire system, you are more than happy to have me. So thank you guys. I'm
So,
really sorry to take an extra 10 minutes. I'm open to questions.
I had a question, not related to KONMA, but a little bit related to cryptocurrencies. Uh, like when El Salvador, when it legalized cryptocurrencies as a legal tender, IMF warned it about the usage and uh, basically uh, said to reconsider its decision. I mean, and also it is illegal for many countries. Illegal Bitcoin is illegal in many countries till now.
So the idea there is basically
Uh, I'm not able to hear you.
can you hear me now?
Huh, huh, huh. I think you are
So yeah,
muted.
the thing is, if Bitcoin actually succeeds for what it is, the International Monetary Fund is basically useless. So they don't want to take that risk. To be very honest, not as any government, not as any sovereign state with their own currency. This is the United
Uh,
States dollar, the Indian rupees, the Russian rubles, the Japanese yen.
yeah,
They've
but
invested.
they raise some points about like the volatility of Bitcoin, and it's not.
Exactly. The volatility of Bitcoin is towards the US dollar. That is how we are imagining it or perceiving it right now. What if in another 10 years you will start comparing the dollar or every other? See, because until now or until 1986, the entire economic foundation has been relying on something called the gold standard, where each valuation of notes somehow is somehow equal to certain weight in gold depending on the demand of gold. But we're not following that anymore. Now we follow something called the monetary policy, which basically means they get to control the current valuation of the economy when transitioned, depending on decreasing or increasing the entire supply. So these details, this information, this power is basically given to the
You are not.
these decisions is not really fair, and you know the amount of corruption and bribery that goes around with this. Now, I'm not saying Bitcoin or blockchain solves this. What Bitcoin and blockchain basically does this is puts this information out in the open.
Sangeet, we lost
It
you
is
in
basically
Sangeet, sorry, we lost you in between.
Yeah, in between you are not like audible.
till where did you hear me?
Uh, Wait, I think you were telling about uh, once when you were telling about the gold standard.
Volatility.
Yeah, so yeah, the volatility is basically based out of Bitcoin's comparison to fiat currencies. This is because we've been following the gold standard for a very long time, and we haven't been following that ever since. So our base valuation of giving a certain thing a price or a value has been flawed. The best way we can do that is through our olden times, which is purely based out of supply and demand. If I am willing to buy something at this much and someone is willing to sell me that at this much, we are both happy and we are both okay with it. That is what happens here with Bitcoin. There is no government to tell you that no, you cannot do this. You have to sell and buy it with this. If I want to buy a house from you using Bitcoin and at that agreed value, then that trade is between both of us. There is no need for, obviously there needs to be some certain policies and protocols, but then those policies and protocols are only in place because humans tend to be flawed and take stupid decisions. In a very nice world, we wouldn't need any of these requirements. So yeah, in the near future, when inevitably people will have to come into the Bitcoin standard, then Bitcoin will be solid. It will be like one Bitcoin is worth $86,000 or whatever. So you will now be comparing fiat currencies with Bitcoin rather than the placebo effect of you comparing cryptocurrencies with fiat right now. The same thing happened with gold. You can ask your parents. The same thing happened with oil for our generation, and now it's going to happen to the currency itself. So it's just a paradigm shift. That's why you don't see any economists talk shit about Bitcoin. You only find bankers and financial
This
institutions.
is like a much bigger argument here because people
Definitely,
all over
definitely.
the world have been like talking about this for a very long time, and actually I would suggest like do your own research, see what people are like saying about it, and you can take a call.
Or just head over to KONMA Hood. Head over to KONMA Hood. Head over to the blockchain tribe. We have a special dedicated place just to hold discussions on these kind of things. Feel free to open any discussions. We have technical analysts, we have on-chain analysts, we have developers, we have a lot of people with a lot of interests from various aspects of blockchain, even legal side if you really want. So yeah, Satya, do send. I think they have the link tree, no, for KONMA Hood.
Yes, yes. So to access Notion, you just have to log in with you have to register yourself, log in, then you'll have access to all the content in Notion.
And we are completely decentralized. We're not hiding any information. If you want any set of information, you'll have to ask us. And the more you involve yourself with KONMA, the more you get to understand, the more you can build.
So right now, all the informations are there in different places, and we are trying to bring a very clear way of communicating all these things. But right now, if you want any specific information, or you don't find you need some clarifications, maybe ask us or just write to us. Maybe we can guide you where the exact information is available right now. So. Yeah, that's about it. If you guys have anything else like to talk about or any other questions, we'll be happy to take.
Okay, I don't have it. So thank you for the.
You're most welcome. Do spread the word to your classmates because you guys can do your internships and eventually get paid. And if you are good enough for the industry, then you'll be employed as well. In any field you feel like.
Like I have not like given them a brief about what KONMA Flair is yet.
Okay.
But maybe I'll reach out to them personally and talk about it. So
perfect.
They'll get an idea what KONMA Flair is and what we do at KONMA Flair.
Awesome. So yeah, I guess you guys got a basic gist of everything, right?
So KONMA Flair, basically like with CMI will be more like a fellowship where you can either be a developer or a researcher or with the blockchain aspect of it. But our Flair program is conducted for many other things also. Like we have law students, we have art students, we have agriculture students, we have biotech students. So all these Flair is like for different sectors, but for CMI, it's more towards the technical aspect and the research aspect of blockchain of KONMA.
Okay.
So if you guys are interested, just write it to us. Like I'll be very happy to take you through how this whole Flair program is like designed in a way you learn in depth about more about blockchain, in depth more about decentralization. A lot of new aspects that are going to be future way of life. So I'll be happy to take you through how it is designed and what is the duration, what are the perks and all those stuff. So just let me know if you guys are interested. Like I'll take you through. So if there is nothing else, I think we can end this session now.
Yes, we can. I'm looking forward to seeing you guys and your friends on the 18th.
Thank you for the course.
Of course.
Thank you, Madhav.
Thank you. So check out the rest of those links and read up on them, watch some videos, and let